Hello and welcome, students. Welcome to today's special revision explainer. I am your host, and today we are going to completely conquer the concepts of volcanoes and earthquakes. We'll be using step-by-step, exam-oriented tricks so you can score full marks. Grab those notebooks, sit up straight, और चलो शुरू करते हैं. Let's make this geography revision super easy and fun.
Here is our syllabus for today. We're going to cover tectonic plates, the fiery world of volcanoes, the shaking ground of earthquakes, decoding seismic waves, and finally, top exam practice questions. Let's get right to it. Section 1. Tectonic plates and movements. Okay, so let's dive into this. The Earth's crust is basically broken up into these massive puzzle pieces called lithospheric plates. But why do they move? Batao kyun? For your exams, remember two absolute key drivers. First up is convection in the mantle. Picture intense heat and swirling melted rock deep inside the Earth just pushing those plates along. And second, slab pull at distant margins. This is where the heavier edges sink down and literally pull the rest of the plate behind them. Samjhe? It's that simple. Moving right along to Section 2, volcanoes, causes, and types. Dhyan dijiye bachcho, pay close attention here. So what exactly is a volcano? Well, in the simplest terms, it's essentially a mouth or a crack right on the surface of our Earth. It acts as a rupture in the upper layer that releases all that intense internal stuff, like hot lava, expanding gas, and thick ash from deep within the Earth straight up to the surface. Now, when you're studying volcanic activity, it's absolutely crucial to distinguish between its two main components. The trick here is understanding endogenous versus exogenous processes. Just think of endo as inside. This process happens completely hidden deep inside the crust, creating magma and gases right in the mantle. On the flip side, exo means outside. The exogenous process is the dramatic stuff we actually see. The lava, volcanic dust, and mud erupting on the surface, creating all those new mountains and topography. But why do they actually erupt? Step by step, there are four main reasons. First, isostatic disequilibrium, which is basically a fancy way of saying an imbalance that causes structural changes. Second, the origin of gases. Abundant underground water falls into deep cracks, turns instantly into vapor, and acts as a massive propellant. It is literally just like a giant pressure cooker. Third, thermal rise, which comes from radioactive materials releasing heat. And fourth, pressure reduction, which causes solid rocks to just suddenly melt into magma. Now for a super popular exam topic, types of volcanoes. Chalo dekhte. For your MCQs, you'll definitely want to note down these examples carefully. First up, the active volcano. These are the awakened giants that are currently erupting or showing really clear signs of bursting soon, like leaking gas or triggering minor earthquakes. Mount Etna and Stromboli are your prime examples to memorize here. Next is the dormant volcano. Basically, a dormant volcano is just sleeping right now. It stays calm for very long periods of time, but there's always that possibility it could wake up and become active again. It brilliantly illustrates how geology works, right? Things might seem quiet, but they definitely aren't dead. Mount Vesuvius is the perfect example of a dormant volcano you need to keep in mind.
And finally, we have the dead or extinct volcano. These guys haven't erupted for a very, very long time and are permanently inactive, even though they still physically look like volcanoes. The Shiprock in the Netherlands is a classic example you might spot in your question papers.
Before we leave volcanoes behind, we have to know where they live. Most of the world's highest volcanoes are found in the Pacific Ocean Strip, which is famously called the Ring of Fire. But please don't forget the other three major zones: the Mid-Continental Strip, which hosts Vesuvius and Etna, the Middle Atlantic Strip, which holds about 10% of the world's volcanoes, and the East Africa Strip. Take it? Awesome. Let's keep moving. Section 3, earthquakes, the shaking ground. Now, this right here is a major exam trick. Examiners love, and I mean love, to confuse you between the hypocenter and the epicenter. Let's clear it up. The hypocenter, also called the center or focus, is the actual starting point of the earthquake deep down inside the crust. The epicenter, on the other hand, is the point on the surface exactly vertically above it. So just remember this trick. Hypo is low and hidden, epi is up on the surface. Let's see how this builds into earthquake classifications. Based on focal depth, meaning how deep that hypocenter is, earthquakes are neatly divided into these three zones. You absolutely need to memorize these specific kilometer ranges. Shallow earthquakes happen between 0 and 70 kilometers. Intermediate ones are 70 to 300 kilometers deep, and deep earthquakes happen way down, between 300 and 700 kilometers deep. So what actually triggers all this shaking? While a sudden tectonic energy release in the lithosphere is the main cause, remember that there are other really fascinating factors too. Massive methane gas migration deep inside the Earth can actually cause quakes. Secondary events like volcanic eruptions and huge landslides cause them too. And yes, even human activities, like underground nuclear tests, can generate seismic waves. Crazy, right?
Moving on to Section 4, Decoding Seismic Waves.
This is arguably the most critical scoring topic of the entire chapter. I highly recommend you copy this exact table right into your notes. Let's decode it together. P waves are your primary waves. They're the fastest, and they travel through all three mediums: solid, liquid, and gas. Then we have S waves. These are slower, and they travel transversely. But here is the ultimate exam trick, Dionsasuno. The letter S in S waves stands for solid medium only. They literally cannot pass through liquid or gas.
Finally, we have our third type, L waves. These are surface or long waves, discovered by a scientist named H.D. Love, which is exactly why they are affectionately called love waves. Now, these waves are limited mainly to the ground's surface. They can actually travel in all three mediums, but they are the absolute slowest, traveling at an average speed of just 3 kilometers per second. But here's the catch. Even though they are slow, because they stay right on the surface, they cause a huge amount of damage.
Section 5, Top Exam Practice Questions. All right, students, it is time for our rapid-fire revision quiz. Let's see what you remember.
Question number 1. Which of the following earthquake belts is known as the Ring of Fire? Read the question carefully, guys. I specifically mentioned this zone when we discussed the volcanic strips earlier. Do you remember? Yep, it's the Circum-Pacific Belt or the Pacific Ocean Strip. That is exactly where most of the world's highest volcanoes are hanging out.
Question 2. Which of the following earthquake waves can travel only through solid materials? Think back to my little alphabet trick from the comparison table for this highly repeated MCQ. Remember? S is for solid. Therefore, the correct answer is S waves, or secondary waves. Spot on. And one last question for today. What causes a tsunami? Think about all the factors we just discussed. What massive geological event happening completely underwater would forcefully displace ocean waves like that? That's right, an underwater earthquake. When the seabed shakes and suddenly shifts, it moves an absolute mountain of water above it, creating those devastating tsunami waves.
Excellent work today, class. You've done a really fantastic job mastering these concepts. But before you go, I want you to think about this. The ground beneath your feet feels completely solid, right? But it's actually constantly shifting, breaking, and floating on a sea of magma. Are you standing over a dormant giant right now? Keep that in mind. Be sure to join our Telegram channel right now to get these exact PDF notes for your revision. And please, like this explainer, share it with your friends, and subscribe to the channel to absolutely ace your next exam. Until next time, keep studying hard.